Hello everyone, how are you? And this video is about flowcharts. Flowcharts are all about planning, and a good plan should flow. What are flowcharts then? Well, they are mostly used in computer programming, and before you start any kind of coding, you should understand exactly how your code will work. In other words, you need a plan. Flowcharts are a way of planning code, but not only code. Any plan can be put down in this form. If you are having trouble planning something that you need to do, try using flowcharts. But be warned, if you are having trouble starting something that you need to do, then a flowchart won't help you with that. We move through flowcharts using connectors, which are shown by these arrows. These connecting arrows are always one way. If you need to go backwards in the chart, then you must make a loop, and we can talk about loops another time. All flowcharts have to start and end though, and the start and the end of your chart is shown by oval shapes. Note the colors are not important. You can choose any color for your flowcharts, but always use the same color for the same kind of object so that your chart is easy to read. We can now make a very simple flowchart. We start breakfast and we finish breakfast. There is no detail, we don't know what happens in between, but this flowchart moves from start to end. Another thing we might put into our flowchart is input and output. Sometimes you need to put something into a plan. This is input. When you put something in, you often get something out, and we call this output. You might think it would be called outget, but remember, it is the code or the plan that is putting something out, not you. Inputs and outputs are shown using parallelograms of different colors in the flowchart. Here we can see a simple flowchart that uses inputs and outputs. We start our breakfast, we input bread, and we output toast, and then we finish our breakfast. Again, you can see lots of detail is missing, but this is a simple flowchart. And here is another example from the internet. We start, we input a name, we output hello name, and we end. This is a classic example of computer coding. You type in a name and then the computer outputs hello name. Our next flowchart object is a process. A process is something that happens with no input needed. Processes are shown by rectangles in the flowchart, and they can be many things. They might be maths functions like addition or division, or maybe something that happens while you are waiting for it. Let's see a couple of quick examples. In our breakfast algorithm, we could start breakfast and then input bread. Then the process is the toast cooking, and so bread becomes toast, and so we output toast before we finish our breakfast. This could also be a maths function. We can start an addition, we input 3 and 4, and those could be separate input objects if we like. Then the process will add those inputs, and if we add 3 and 4, then we get an output of 7 before we finish our addition. Finally, for this video, we come to a decision. Decisions are a bit different. They have 2 arrows coming out of them. What do you think those arrows are for? The arrows are for the Boolean outputs, true and false, or yes or no. This is how we make decisions one way or another in our flowchart. And so this is why decisions have two arrows coming out of them. A decision is shown by a diamond shape in the flowchart. Let's look at this example of a flowchart to decide if a person earns enough money to live alone. We start and we input an hourly rate of pay. We then input a number of hours per week, and we go to a process where the hourly pay multiplied by the hours per week gives us weekly pay. Weekly pay is now something called a variable which we can store in our code, but we can talk about those in another video. In this example, we just go to a decision. If weekly pay is greater than 400, then the output is true, and so we say yes, this person can afford to live alone. If the weekly pay is not greater than 400, the output is false, and we say no, this person cannot afford to live alone. Let's look at our breakfast algorithm for a slightly more complex example. I won't go into all of these details, but follow it through for yourself. In this algorithm, we start our breakfast, we decide if we want to eat cereal or toast, and whichever one we say yes to, there are inputs to follow through to processes. If we go for cereal, we have an extra decision. Do we want crunchy cereal? If yes, then we output crunchy cereal. If no, then you wait 5 minutes, another process, to output soggy cereal, and then we eat the cereal either way. If you don't want cereal or toast, then there is a process called no breakfast, which takes us straight to finishing the breakfast we did not have. Of course, those examples were quite silly and a little bit over simple. We can add more steps to these flowcharts. We might want to choose many different types of cereal. We might want to have butter or jam or honey on our toast. In the earlier example, we might want to add more details to the cost of living. Where does the person live? How much do they eat? Do they have children? Whatever you do, remember that adding more detail will probably add more decisions, and every decision must be a yes or no question. So more detail will add a lot more complexity to your chart, but it does mean a detailed plan. This is often a good thing, but not always. It is possible to get stuck in details that don't really matter. Be careful about this. But if you want to be a good coder, you will need to practice thinking through everything you want your code to do and breaking it down into the smallest and simplest number of steps that will get all of it done. Here we have a table to summarize all of the coding objects that appeared in this video. Again, it's from a great web page which goes into more detail on how to use flowcharts and how it links to code. We might look at that in a later video, but the link is in the description. A flowchart will start and end with oval shapes that show a start or end point to a code or to a separate piece of the code. All flowcharts have connections, arrows which are one way only, which move us through the flowchart. A process is shown by a rectangle, and this could be a mathematical function or something that computers or the world does without needing any inputs or decisions. Inputs and outputs are shown by parallelograms, and they show things that we have to put in or get out of our flowchart. It says there print is normally an input. This is because when you tell a computer to print something, that is an input, and when the computer actually prints it, that is the output. And finally, there is the decision or conditional. These are shown by diamonds, and after the decision, you either take a true or false value, a Boolean yes or no. The notations in the table, if, else if, elif, while, and for, are words we can use in code to tell the computer exactly how to use these Boolean outputs. But all of that is for another video. Thank you for watching.